Hello, welcome to the electrical engineering class. The last time we learned basic operation of induction motor control circuit by using this actual device and this wiring diagram. And in this video, I want to share you how built this actual wiring from this wiring schematic diagram. So let us begin. Let me disconnect each wiring. Okay, so this condition is that each device are installed without wiring. Alright, so let us build our load circuit side. I mean, this section is load circuit, also called power circuit. It's so simple. You can just connect power supply and circuit breaker and magnet contactor and thermal protection relay and load motor, three-phase motor. By the way, this magnetic contactor and protection relay is connect just this three-phase, like this. Okay, three-phase. Sorry, three-phase. All right, three-phase. Okay. By the way, it's so helpful when you need to strip a wire. This stripper, right? Right. Take this terminal cap and this terminal. Use this, I'm not sure how to say in English. Okay. 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 Okay, so the power socket side is done. It's so easy, right? On the other hand, the control circuit, we can say in this section control circuit. Control circuit wiring is a little complicated compared to the power circuit. Okay, let's begin with this wire, right from our phase to the terminal of fuse, and in the control circuit, every wire should be assigned any number or name tag. So let's say it's connected to the R phase, so let's say the name R, right? So we need to create each wire with each assigned name or number, like this R. Okay, R, right. It's so helpful, so I recommend to assign each name like this. So some people confuse this wire, which comes from the middle of the other wire. So how exactly build it? Or is it strip the wire in the middle position and connect? Of course not. It connect any terminal of this wire. So you can connect this position, this terminal, or this terminal. Both terminals are fine. It's up to you, right? So I just pick this one, right? This terminal, because it's more close. We needed to connect this the fuse terminal, so it's close than this one. Yeah, but if you want connect the another terminal, that's okay. No one force you. Okay, similarly, you can wiring according to the diagram the rest of the circuit. And be careful when you connect a device which has a contacts like relay. So I mean, you should be sure the terminal which you are trying to connect is normally open or normally closed. So if you confuse the state of contacts, you can check by multimeter resistance range. Normally close are always 0 ohm, and here beep like this, and normally open contact is infinity. And the magnetic contactor and the push button also can check the operation state manually, like, you know, this is normally closed, and if coil excited, it's turned to open, like this, and back to the original. Also push button, you can check this is normally open, and if push it, it's closed, so it's normally open contacts. But the relay, at the relay, you can't check the operating state without power supply. So they can't operate manually. So only way to check the excitation condition is by applying the actual voltage to the coil. But the detailed specification, including contact state, is drawn in a body of the relay. I think it's too small for camera. Sorry. You can check it to reference. Okay, all wiring are done. However, please don't apply power supply before some safety confirmation. We need to confirm there are no failure, like no short circuit and no ground fault. Sometimes such a dangerous failure happen by long wiring. So you can check short circuit by a multimeter resistance range, same as the confirmation of the contacts of some relay or magnetic contactor. So you can check resistance and check the off state, and I recommend before check the resistance. There are no volt. Okay, no volt. So check the resistance. Okay, not short. Okay, not short. And be careful, each section isolated. This is isolate. So if you can check all section or switch on manually, like it's okay, it's just a resistance of coil, not short circuit. Okay, the condition of short circuit, like 0 or very few resistance, like 3 less than 3 or 0 ohm, like that. And we can check, we needed to check the ground fault by using this insulation ohmmeter. Okay, so let me check. Okay, fine. Okay, no ground fault. And no ground fault. All right. Okay, as is fine. Okay, so the details of this apparatus, insulation ohmmeter, I'll explain maybe next video. So safety are secured. Let us operate. What? Oh, sorry, I forgot the short circuit of this fuse. Okay, here. Sorry, I forgot it. And I rechecked. I checked the safety again in this state. So let's start. Okay. Okay, fine. So let's just end here today. And the next video we will learn troubleshooting of control circuit and the difference between each failure, like short circuit and overload and ground fault. And if you have any question, please contact me. Don't hesitate. So thanks so much for watching, and see you in the next time.